Okay, you're student Professor Dr. Dolphy Gilpin here at a Holiday Inn in New Orleans, and we are still on the amazing 5x12 matrix and its stochastic extensions. We have the 15 by 12 and also the 27 by 12 sunflower matrix. But in this application, we're doing some circuits, and what we'll do, we'll just draw the circuits, and we have done the solutions in other application, in other settings. So let's and let's know how for the 5 by 12, we have a little rotation here. And so what we'll have here now, we start off from the basic circuitry. And with some inductance. And we have a voltmeter here. And we have a current going so. And these are resistors. This is the inductance and this is capacitance. And for the 2 by 2, we had circuitry looking like this. And I'm just drawing circuitry randomly now. Rather, we'll put it, this representing an emitter. And usually we use voltage cell looking like that. So let's have a volt cell there. Inductance and capacitance, which will sometimes bring some complex solutions. All right, so for this we'll have a tree. Let's draw it a bit shorter here. Voltmeter. Inductance, capacitance, and the third one, this will be for the 3 multiplied by 3. This will be for the 2 multiplied by 2. Obviously, these resistance are arbitrary or unknown. Inductance, usually represented by L, and resistance by R. Inductance by L, resistance by R, call this 2. So we move on to the 4 by 4 solutions, and we could probably put just do like that. Capacitance, resistance, inductance, and my arms here, the blood seems to be uptight. So let's just put it like so. That represented the voltmeter. It's representing impedance. It's representing capacitance. And so we have that. And so we have resistance and inductance. Capacitance there was that. And so for this we say this represents our 4 by 4. principle, when you truncate the 5 by 12, we could have a 5 here now. Inductance. Capacitance. And that, or the resistance there. Series, capacitance. I will leave notice here we could, after putting in the elements of the matrix, usually in resistance, and doing that, we could we now have matrices calculators that can simplify our solutions. Let's use a double voltmeter there, a 2-cell, and this will be for a 5 by 5. Call it. I'm drawing it in simple to like that. If during the solution we get a negative, then it means then it's in the reverse direction. And in principle, we could extend these to 6 by 6 and so on, and 7 by 7. Since we have 15 by 12, we could have making our circuitry more smaller and smaller and smaller. 12, 7 by 12, we could have usually have some microcircuitry. Anyhow, let's see here. All right, so let's do that, representing space to the nth circuitry. To the n, and here to the n. And so we call this n multiplied by n, where n represented 1, 2, 3, to n, or n by n, and n 1, 2, 3, to n. When it's square, we could call it n by n. If it's not square, then let's have 4 and 5, and proceeding after 5, then we'll have to the n. And let's now put now for the circuitry. R equal resistance, L equal inductance, C equal capacitance, current, ammeter, and voltage cell, What we have, S equals science application. We also have social application. It's a multidimensional, multi-field application. And T is equal to teaching. Technology. E equals engineering. And E also equal economics, especially when we use those monetary serials and infinity output, exponential output. And notice that I have applied these over to the Federal Reserve chair in Greenspan up to Dr. Bernanke and Yellen and Powell. All of these have received a sample of the proof of exponential to infinity output and the prudent application in economic and monetary output, monetary economics for mint application. STE, M. M equals now mathematics, music, medicine, mathematics, and music. Also, so we have the A now. When it's gone to STEAM, it becomes now architecture. We also have aviation. We also have aeronautics. Astrology. Anatomy. And R equals more real estate. Which will include housing, real estate application, and B equals business. So there we are. To conclude our presentation here at the Holiday Inn in New Orleans, Louisiana. These things can be applied to reduce the poverty, not only in America, but elsewhere internationally. And bring about improved quality of life for the human family. And if there be any goodwill family, then it also can be applied to beings of goodwill to humanity. Okay.